After the end of World War II, priorities in military technology underwent significant changes. If after World War I, armored vehicles or combat aviation were considered revolutionary breakthroughs, then by the middle of the 20th century, the lead had shifted to weapons capable of determining the fate of entire nations in a matter of minutes. In the 1950s, intercontinental ballistic missiles entered the stage, capable of delivering a nuclear warhead to the other side of the planet, leaving the enemy no time to react. The Cold War created an atmosphere in which technological progress turned into a race where every mistake could cost a country its prestige and millions of lives. Against the backdrop of all this tension, a new rocket design bureau, OKB 586,
Don't forget to like, subscribe, and leave a comment. Your support helps the channel grow and motivates me to create even more amazing videos for you.
also known as Yuzhnoye, was established in the Soviet Union in 1959. The task set before it was quite challenging: to create a carrier capable of striking the territory of the United States in the shortest possible time and with maximum power. In the new project, Soviet engineers decided to use the experience gained during the development and testing of the R-7 rocket, which was a symbol of the first Soviet space victories. Based on it, work began on a fundamentally new and much more powerful rocket, the R-16, whose launch mass reached about 140 tons. To increase range and efficiency, a risky decision was made to switch to a different type of fuel. Traditional components were replaced with an aggressive and deadly dangerous mixture. Heptyl, an extremely toxic substance, was used as the fuel, while nitric acid enriched with nitrogen tetroxide served as the oxidizer. Yes, I understand, these are complex terms, but it's necessary to know them for an adequate understanding of the following context. So, let's continue. This combination provided a much greater impulse, but created dangerous working conditions, since even brief contact with these substances could lead to severe consequences. The choice in favor of this fuel was a kind of extremely dangerous experiment. Speed and power were traded for increased risk and vulnerability during launch preparations. The new fuel mixture opened up enormous technical prospects for the designers, and its power was sufficient to easily deliver a rather weighty argument in the form of a nuclear warhead to the territory of the United States. But behind this potential lurked a dark side, namely explosiveness, which left no room for error. During the fueling of the missile, any accidental contact or even a microscopic leak could result in a very unpleasant and large-scale explosion. That is why technical instructions required extremely strict safety measures, such as a precise sequence of actions, protective suits, and multi-level inspections. But in the conditions of the Cold War, safety was often compromised, since the main priority was following orders. The Kremlin set a strategic task for the designers: to create a carrier capable of deterring the United States from any aggressive actions. And the sooner the missile was put on combat duty, the better. The pace of creating this wonder weapon was incredibly fast, and just 6 months after work began, the first prototype of the R-16 was delivered to the Baikonur test range, and, as is customary in Muscovy, the launch time was scheduled for a symbolic date, namely the anniversary of the October Revolution of 1917. And although the first test was scheduled for October 22, 1960, the preparation itself turned into a marathon, where each day was consumed by haste and technical compromises. By the time of the launch, even according to official data, 70 serious deficiencies had been identified and eliminated. Each of these, under normal circumstances, would have been grounds to send the rocket back to the factory for a thorough analysis and correction. But this time, all the modifications were carried out directly at the test site, in field conditions, without a complete set of calculations or thorough testing, often under the open sky, and sometimes just a few hours before the next stage of work. The pressure of time and politicians forced the engineers to work in an environment where every decision was a compromise between technical correctness and relentless haste. It was a race in which no one wanted to lose, even if the price of victory turned out to be too high. All the difficulties and warnings from the engineers meant nothing in the face of the strict orders from the party leadership, and the launch deadlines could not be postponed. The date was set, and preparations were underway as if nothing could stop the process anymore. At the appointed time, the chief designer of the project and the military command arrived at Baikonur. Among those present was also the commander of the Strategic Missile Forces, Marshal Mitrofan Nedelin, who had held his position for less than a year at that point, but had already managed to immerse himself deeply in the details of the new weapon system. He closely monitored the preparation process and even made quite reasonable suggestions to the designers regarding improvements to the system. But the problem lay elsewhere. Any improvement, even the most useful one, required time and calculations in factory conditions and in the field realities of the testing ground. Among open-step winds and metal structures hastily assembled, it was almost impossible to implement. Sometimes it was necessary to resort to solutions that engineers under normal circumstances would not even consider. One of these solutions, for example, was the rocket's electrical circuits. According to the design, they were supposed to be made using special materials resistant to high loads and aggressive environments. But as a result, the necessary components simply weren't available at the right moment. Instead of the standard cables specified, only ordinary wires were found in the warehouse, which were not at all suited for that level of voltage. Their insulation began to melt already during installation, and minor damages became sources of potential short circuits. This problem was recorded more than once. Twice, defects in the wiring were found even before the rocket was sent to the test site, and both times they were hastily patched up so as not to delay the schedule. Did you think that 2 times was the end? Of course not. The third time the problem was noticed after the R-16 had already arrived at the launch pad. Here, without access to specialized equipment, the specialists had to act using improvised methods. They searched for any materials that could reinforce the damaged areas. They used the first rubberized membranes they could find in the warehouse, along with additional insulation pads that looked more like a temporary patch than a serious engineering solution. All of this only postponed the moment when the flaw would make itself known again. But in an environment where every minute was precious and political propaganda outweighed technical feasibility, such compromises became the norm. And here's another interesting fact about the materials they tried to use to fix the wiring flaws. They weren't taken from rocket manufacturing at all, but were found in an ordinary car repair shop, which, to put it mildly, is quite far from the standards and norms that strategic equipment should meet. These improvised solutions carried a hidden danger. But again, the main enemy was time and most likely the party. The initially planned launch was postponed by only 1 day, from October 22nd to October 23rd. But even this extra day did not allow them to fully eliminate all the malfunctions. While preparing the launch pad, the members of the Acceptance Commission were stationed in a special protective bunker built just 100 meters from the launch site. Formally, this structure was supposed to withstand significant impact loads, but everyone understood that in the event of an accident during launch, the chances of saving the people inside were practically non-existent. It was no coincidence that among the military, its unofficial name became the Crypt. The final launch rehearsal brought new unpleasant surprises. Guess where? That's right, the electronics again. During the inspection, a short circuit was discovered in the separation system responsible for jettisoning the rocket's second stage. This is a critical component, and under normal circumstances, its malfunction would automatically mean halting all work and sending the unit back to the factory. But under pressure from the command, it was no longer possible to change anything that drastically. So the decision was made instantly. They simply forced the engineers to fix the malfunction right there in the field. Immediately after that, preparations began for the most dangerous stage, namely fueling the rocket with a highly toxic heptyl nitric acid mixture. And although the problems with the components and systems did not go away, the work was completed to the end. The fuel was loaded, and only then were technicians allowed access to the rocket for additional inspections. It was at that moment that they decided to postpone the launch again, this time to October 24th. This meant that a fueled, explosive carrier with officially documented technical defects was standing on the launch pad. According to the instructions, such a device should not have been allowed to undergo testing at all. The situation was completely unacceptable because allowing a repair crew access to a rocket already fueled with toxic propellant was a blatant violation of all regulations and, frankly, of common sense. According to all the rules, before starting repairs on the electrical wiring, it was necessary to completely drain the dangerous fuel mixture from the rocket. But that day at Baikonur, they decided to do things differently. On October 24th at 6:40 p.m., a 30-minute readiness signal sounded over the launch pad. Marshal Mitrofan Nedelin personally observed the progress of the operation. They even set up a temporary observation post for him right at the launch site so that he could see everything with his own eyes. Mikhailo Yangel, the chief designer, was also nearby, but a few minutes before the launch, he stepped out with his colleagues for a smoke break, moving about 100 meters away from the protective bunker. The first seconds after the start of the test seemed completely successful. Commands were being executed, systems were working, and it even seemed that previous problems were a thing of the past. But this illusion did not last long, just 3 minutes. Then, Baikonur found itself at the center of a fiery apocalypse. In an instant, 120 tons of heptyl nitrogen fuel mixture ignited. The flames burst out with such force that even the metal structures of the launch pad began to melt under the heat. The temperature of the fire reached such levels that within an area of several dozen meters, no living creature could survive. The ignition wave lasted less than a minute, but that was enough for everything to turn into a hellish cauldron. The fire swept across the site, scorching and melting everything in its path. The cause was the automatic ignition of the second stage engines. And once again, it was due to problems with the electronics. The fire from the running main engine burned through the bottom of the oxidizer tank, and the toxic liquid burst out. The mixture ignited instantly, turning the launch pad into a blazing trap for dozens of people who, just a minute earlier, had been standing nearby. The flames erupting from the rocket were completely uncontrollable. Trying to extinguish them was pointless because there was still too much fuel left in the tanks. Marshal Nedelin, who just minutes earlier had been personally overseeing the launch preparations, disappeared in this blazing trap. Nothing recognizable was left of his body. The only things found among the wreckage were a piece of his overcoat, a single shoulder board, and the melted casing of his watch. The hands were frozen at 1843. And that is the exact time of death of the Commander-in-Chief of the Strategic Missile Forces. The very next day, official Soviet newspapers briefly reported, Marshal Nedelin died in the line of duty. Not a word about the large-scale disaster. In reality, that evening the fire claimed, according to various estimates, from 78 to 126 lives. And among them were both leading engineers from the design bureau and ordinary technicians who followed orders until the very last moment. Mikhailo Yangel was miraculously saved because, as you may recall, he had stepped away for a smoke break just a few minutes before the explosion. Despite the fact that he was the one in charge of the project, he was not punished. Serhiy Korolev personally appealed to Nikita Khrushchev, defending his protégé. He argued that new technology always bites at the beginning and that problems at the start are inevitable. After the tragedy, a strict list of new requirements and regulations was introduced. From then on, safety became the key condition for any launch at the test sites, although this point still remains questionable, considering how generally negligent the USSR was about many types of work. In the archival collections, which for a long time were kept under the label Top Secret, there are materials indicating that the tragedy at Baikonur was classified for almost 30 years. The families of the deceased received only brief official notifications, died in the line of duty. Among the victims was Lev Abramovich Berlin, a designer of rocket and space technology, and deputy chief designer under Yangel. In one of the discovered documents issued by the military unit, it is dryly stated, Comrade Lev Abramovich Berlin died in the line of duty on October 24, 1960. And the signature, Commander of the military unit, Colonel Balanchuk. In another case file, a telegram has been preserved signed by a representative of the Ministry of Communications of the USSR concerning Valentin Pugarevich, the driver of the refueling and special fuel delivery team of the first launch group of the separate engineering and testing unit. The text of the telegram is no less dry and emotionless. Your husband, Pugarevich Valentin, died in the line of duty. The funeral will take place on the 27th of October. No explanations or details, just dry official language that concealed the horror of a large-scale catastrophe. The press at that time reported something completely different. An article about Marshal Mitrofan Nedelin was published with a sensational headline, but with a completely false cause of death. He died in an aviation accident. Not a single word was written about the explosion at Baikonur. 48 officers and soldiers were buried in a mass grave in the park of the city of Leninsk. The civilian specialists whose bodies could be identified were sent back to their hometowns, to various cities and villages across the Soviet Union. They were buried without any honorary ceremonies or military salutes. Employees of OKB 586 were often buried even without exact dates of death on their tombstones. For the official record, it was as if they had simply disappeared. This incident at Baikonur was far from the only one, but it became the largest and most terrifying in the entire history of Soviet rocket technology, and most importantly, it was a catastrophe that was kept secret for decades.